Welcome Math 252. We're working on problem 69 from section 6.2 of the Hughes-Hallett text. In this problem we've been asked to calculate the exact area above the graph of y equals sine theta and below the graph of y equals cosine theta for theta values between 0 and pi over 4. First thing I'm going to do with this problem is draw a picture so I can see clearly what it is that I'm trying to do, and then I'll see if I can't maybe use an integral to figure out this area. So here you see I've drawn a graph of the sine and the cosine functions for theta values between 0 and pi over 4, and I've sketched in light gray the area that it is we're supposed to find. And in the region we're looking at between 0 and pi over 4, you can see that the cosine function is higher than the sine function. They actually meet right there at pi over 4. And you know that if you want to get the area between two curves, and one curve lies above the other curve in the region you're interested in, then you take the curve on top, in this case that's the cosine function, and you subtract the curve on the bottom, in this case the sine function, and you integrate over the region you're interested in. That works as long as one function lies completely above the other, or if they just touch. So I've written that area. The area is the integral from 0 to pi over 4 of the top function, which is the cosine of theta, minus the bottom function, which is the sine of theta. So now I'm going to do a little bit of algebra. I'm going to split this into two integrals. That's the integral of the cosine theta from 0 to pi over 4. And just to make it easy to see what the antiderivatives are, instead of writing minus sine theta, I'm going to write plus the negative of sine theta. And I'm going to split across that plus sign, and I'm going to have the integral from 0 to pi over 4 of negative sine theta on the right-hand side. Now I need to find antiderivatives for these two functions, the cosine of theta and the negative sine theta, in order to evaluate the definite integrals. I've arranged that to be fairly easy. You should know that the derivative of the sine is the cosine, which says that the sine of theta is an antiderivative for the cosine, which says that we can evaluate this definite integral by looking at the sine of theta evaluated from pi over 4 to 0. Similarly, you should know that the derivative of the cosine is the negative sine, so we can evaluate this second definite integral by looking at the cosine of theta and evaluating it from pi over 4 to 0. And so I've done that calculation. We see the sine of pi over 4 minus the sine of 0, which is 0, plus the cosine of pi over 4 minus the cosine of 0, which is 1. And if you simplify that, you get the square root of 2 minus 1, which is what we were looking for.